Hello everyone, welcome to CYBR 708, Cybernetic Systems Design and Dynamics, Learning Activity 7, Data Acquisition and Sensors. And for this week we're going to be going, we'll have 2 lectures, no labs, but I do expect that you keep moving along with Loopy for system dynamics, as well as the Sage Modeler for modeling dynamic systems. And you just keep practicing up with that, because I do have an expectation for those. Remember that for your project and your research design for this course, you'll want to integrate a dynamic model as it relates to your research design. So you want to have that integrated, but additionally, you need to illustrate that you have your model, that your model is dynamic, and that it is thought out and architected from that perspective. Okay, so for our first lecture for this week, we'll talk about data acquisition and sensors, and then we'll get into a little bit of learning methods for our second lecture. But there'll be 2 short lectures, and then I'll be handing you off to your next set of professors for the second half of the course. And they will be both managing the lectures as well as your learning material, as well as the next set of assignments. So, okay, data acquisition. So when we talk about data acquisition, there's two acronyms you might hear: DAQs or DASs, both related to the same thing. Just depends on the paper you might be reading or the industry that you might be in, but DAQs are pretty common, especially when you're talking about autonomous systems, or you're talking about manufacturing assembly lines, whether they're tethered systems or untethered systems or bodied or unbodied. Almost every type of autonomous system is going to have some form of a data acquisition framework within it. And it's kind of the old adage around: you can't improve things unless you have you can't manage what you don't have measurement around, right? You can't and if you have measurement, that's that's critical to the smooth operation of an organization, to the smooth operation of really anything, your own body, right? If you don't have feedback, right, sensory data incoming, or a data acquisition system, then you have no way to measure your performance within an environment, right? Or measure, your body has no way to understand how to move within an environment. And that goes for the same for whether it's a UAV, a UGV, or an underwater robot, a submersible, or something like that. So there's just no way you get around the autonomous systems world without having some form of data acquisition, and then data capture, right? Data storage, not just acquiring it, but storing it as well. So what are data acquisition systems? So what are the key components? And here's kind of a straightforward one. That's a kind of National Instruments, a DAC card 6715. And there's all kinds. This is just one that I pulled off of the internet real quick. But if you put in data acquisition systems, or DAQs, you'll find a bunch of different styles. And a lot of DAQs, they'll have of course sensors, they'll have signal conditioners, because not all the data. I was just at the Air Force Academy, and there was a telemetry uplink, and that's a data acquisition system. They had a DAQ that was hooked up to an O-scope that was checking the spectrum, the optical spectrum, and how well the signal was coming from satellites over the air, right? So that's just some of the things that, it's purpose built. So data acquisition systems are there's just no one unique catch-all, right? There's different sensors, there's different systems, there's different signal conditioners, there's different ADACs or ADCs, data processing units, data storage units. There's just all kinds of different mechanisms. But each DAQ has some form of everything you're going to see over here on the bulleted list here under the DAS, which is sensors and digital processing units and data storage. Some are more combined, right? So it just depends on the sensors that they're connected to. Some are a little bit more integrated than others, but that all comes down to the architecture and who's building it. So architectural components. So if those are the different pieces of it, kind of at a lower level, here's some stuff at a higher level to be thinking about. So you have your sensors and your actuators, and those are absolutely critical to a DAQ architecture. Of course, you have the hardware itself. So you have digital signal processors. You have processors that, because remember, almost all sensors have some kind of form of analog to digital. They're analog measurement devices. And they're almost so many of, and when we say analog, it's some form of physical / mechanical signal detection that then needs to be translated into a digital value, and then that digital value needs to be synchronized from a timing perspective, and then from there, then it can be dumped to like a SQL server or a JSON file or some kind of flat file or some kind of data storage device. There's almost always some kind of form of analog to flat conversion process before you take the flat to a relational system. And you don't always have to go to a relational database. Some will stay or store data in a flat form for purposes of speed. So there's some pros and cons from that perspective. But the other thing that DAQ software and any of these, right, is that DAQs, I know I said autonomous systems, but they can be non-autonomous systems. Like I can have a DAQ system for a flight computer, let's say, in a piloted aircraft. This is just kind of an emphasis on what I'm talking about from a cybernetic perspective. I just wanted to also emphasize that autonomous systems are also a big component of DAQs. So then, of course, next up is you have DAQ software that allows you to do the data analysis, visualization, but also how data gets stored, configuring, controlling the hardware. Usually it happens through some kind of DAQ software. And of course, there's the computer and usually a workstation or something like that. Usually there's some kind of, where the software runs, you've got some kind of centralized workstation for managing all these. And in some cases, your DAQ hardware plugs directly into the computer. It could be remote single board computers, or it could be centralized computer. There's just different architectures. But usually there's some form of a computational device that works in conjunction with the DAQ hardware. Okay, so I want to run through a couple examples, and then I think that'll just about wrap up sensors and data acquisition systems. But here's one that is actually based on what's called a structural health monitoring and actually vibration monitoring for buildings. And this is a DAC system for a long-term continuous monitoring of, like, so if the ground shifts or if there's an earthquake. Usually a lot of big buildings, especially more advanced architectures that have thin, they'll either be non-standard building architectures, and they kind of will push the boundaries of physics, and then they require special mechanisms to help counterbalance. And so DAQs are built. There's some really neat ones, and really, really tall skyscrapers. Almost all big skyscrapers have some kind of counterbalance system. So as the building sways, they have these huge counterbalance counterweights within them to help keep the building structurally sound while moving on really big, being built rather on really big footprints geologically. Because you think if you're standing on your own 2 feet, it's like not a big deal. But if you have a really big structure, you need a DAQ system that can actually there's so much movement in the earth. The earth is constantly under movement, but also buildings are constantly being moved by weather phenomena. So DAQ systems are especially important in architectural development and design of buildings. Okay, next up is here's one for a test facility. There's a data acquisition for a test facility that in this case it's a vacuum chamber for spacecraft propulsion testing. And so this is one that is an interesting one, but you can see how we went from high level to one that's low level, and we're talking about testing of spacecraft. And even in this case, this one is actually purpose built for propulsion, testing for propulsion, and potentially, I imagine, attitude determination and control systems, ADCS systems for a spacecraft. So, so there's in this case, there's I put a little bit more if you want to learn more. This is a little bit more technical, but this paper actually goes into a lot more detail on the National Instrument DAQ system that they built, which is multiplexed, and they have a signal conditioner that's an SCXI system, and it's got quite a few channels and a nice sampling rate and a 12-bit analog digital converter that they have. So it's something that for us, again, from an architecture perspective, you can see where DAQs, again, I'm just illustrating this because it's goes all the way up from big stuff to smaller stuff. So next up is this one that's in ADCS system. This is a attitude determination and control system for spacecraft. And so if you're interested, I highly recommend, let me see here. Let me see, I'm gonna pull up the video. I want to show this to you real quick. And okay, so this is an ADCS for a spacecraft, and these are reaction wheels. And to do the testing for these, you have to have this is for spacecraft attitude determination. So this is orienting pitch roll yaw using nothing more than just these reaction wheels, and they actually are able to make an attitude, one to determine attitude, but then control attitude of the spacecraft. So this is a fun video. There's a link actually in the presentation that's about this, but and pause this here and then come back to oops, I don't want to duplicate, and come back over here and then swap. Okay. And so when we're talking about we just kind of keep going smaller and smaller. So DAQs, data acquisition systems, go from the very large to the very small. And in this case, I have a DAQ system that allows me, and you have to have something that gives you some immediate feedback so that you can create efficient control. And in this case, you can't do that without a DAQ system in place. This is a perfect example. ADCS systems for satellites is perfect for illustrating this at a smaller scale. Okay, so you might be asking yourself, all right, well, these are all great, but these are all really big industrial use cases. But DAQs are very accessible. We actually, there's a link here on Amazon. If you go to Greek Pi, Raspberry Pi, this is a software slash, I would say, systems engineering toolkit. This one actually integrates with the Raspberry Pi. If you look at this, I've got ultrasonic sensors. I've got servo. I've got a Pico breadboards. I've got half-size breadboards. I've got a stepper motor. I've got a potentiometer. I've got temperature sensor. I've got vibration sensor. I have pressure sensors. I have moisture sensors. I've got a bunch of stuff. I've got a photoresistor, so a light sensor. I have a lot of different sensors that I can integrate with the Raspberry Pi and create a DAQ on the cheap. And so this really is pretty interesting because, I mean, this kit specifically probably runs all of 40, 50 bucks. And it comes in a nice little kit. And we have something similar that we use. It's a cybernetic project, a CPK, cybernetic project kit. And it's part of our MLAS 200 course for our undergrads. But we actually expose undergrads in our program, our machine learning program, to cybernetic principles, of course, very early. But they also understand DAQs, data acquisition systems, pretty early too, and within their first year. So these are very, very accessible. And even though I showed you a lot of stuff from a higher level, these are accessible frameworks to build it in like home labs, so to speak. Okay, so I think that's all I have for this. We're at 17 minutes, so perfect. I didn't want it to be too long for this week's lectures, but I hope you found that informative. Please do keep this in mind. I'm keeping this at a kind of a high to mid level. We didn't go into too much detail on the data acquisition systems, and the reason I'm keeping it kind of broad is because I'm expecting you to dive into the details as per your project. Each DAQ is going to be different, and each DAQ for your given project is going to have a different architecture, and it's something that kind of evolves as it relates to, again, your research project. So you will have to dig into the details as it relates to your own DAQ system. But I do want you to keep that in mind. I do want you to keep that as something architecturally, something that you be cognizant of as you're building out your research design, because these things are pretty important. Okay, that's all I got, and I will see you in the next learning activity.